So now we're going to talk about just what are the laws, the law of sines and the law of cosines. Here we go. So the law of sines, law of cosines. And the key is this. These laws are true in any triangle. In any triangle, in every triangle you could even conceive of ever drawing, these statements are true. Now, we know that there's a statement that's true for all right triangles. We know Pythagoras is true. The Pythagorean theorem holds in all right triangles. But these statements hold true in any triangle of any sort, any kind, anywhere, any which. Now, so let's talk about the law of sines a little bit. I'll show you where this comes from. I'm not going to go through the argument to develop the law of cosines. It's a little lengthier and it's not quite as illustrative. But it is, in fact, these are in fact true statements. The proof of those are in the textbook if you're interested. The law of sines comes from this. Let me first show you where it comes from. If we consider any triangle at all, let's call this A, C, B. So here's a little a, here's a little b, and it turns out this is little c, but we don't care about it. I'm going to drop a perpendicular. Take any triangle we want, drop a perpendicular from C to side AB. And this is true even if the triangle is obtuse or a right triangle. No matter what the orientation, this is going to be a true statement. But this illustrates what's happening here. Drop a perpendicular. Call this distance H. It's the height of the triangle. If we were trying to find the area, it would be 1/2 the base times the height. This would be H, the height. And now, break this picture into two pieces. Here's the piece on the left. This is A. This is D. This is now a right angle. This is C. This is H. And this is little b. And then this piece of the picture, this is triangle, this is a right angle, this is D, this is C, this is B, and this is little a, and this is H. Now, C has gotten split into two smaller bits. It turns out we don't care about C. Now, we know in this triangle that look at angle A, sine of A. This is a right triangle, so we do get to use SOHCAHTOA. In the original triangle, we don't get to use SOHCAHTOA because we don't know for sure this is a right triangle. But as soon as you drop this perpendicular and break these two pieces, each of these is a right triangle. So we do know in the triangle on the left, we do know that sine of angle A is opposite over hypotenuse. Multiply both sides of this equation by B, and we get B times sine of A is equal to H. What I'm doing here, you do not need to be able to reproduce. You do not need to be able to reproduce this. I'm just showing you where this rule comes from. Okay, so that's true for this triangle. Now, same song, next stanza. Do exactly the same thing on this triangle. Sine of B is opposite over its hypotenuse. So we know sine of B is this opposite, H, over this hypotenuse, A. Multiply both sides by A to clear the fraction out. A times sine of B is equal to H. But look, this is equal to H. This is equal to H. Therefore, they must equal each other. So we have sine of A times B is equal to A times sine of B. We know those must be equal because they're both equal to H. And then the only thing left to do is divide both sides of this equation by AB. Here the B's cancel, here the A's cancel, and we're left with sine of A over A is equal to sine of B over B. And to get, if you want to do the sine C, just drop the perpendicular from a different angle and go through exactly the same argument, and you'll get sine of C over C also. So by an exactly similar argument, we also get sine of C over C, and that's the law of sines. Now again, you do not need to be able to reproduce that. What you need to be able to do is take this formula, take this law, and use it to solve the triangle. You don't need to be able to reproduce it. This argument, this is a proof that the law of sines actually is correct. What you need to be able to do is to use it to solve the triangle. A different argument could be used for the law of cosines. Now, the law of cosines is a little bit different. It looks like there's 3 laws here, but there's only one. It's one rule, but it's from the perspective of the various angles. That this is A, this is B, this is C. Here's a little A, here's a little B, here's a little C. If your perspective in this triangle is angle C, then we use this top because that's the one that has angle C in the expression of the law. If in the problem, for whatever reason, suppose you're given angle B, well, then you would use the rule which has, you would use the second formulation. It's only one law, but it's formulated differently based upon which piece of the triangle you might be given. And then similarly, if you know angle A, then you would use this third formulation. Now notice, this is the key. It's not hard to remember what these are. Notice that if you start, each of these, it's Pythagoras with a little extra stuff thrown on. You see, this is Pythagoras, Pythagoras, Pythagoras with a little extra stuff thrown on. The little extra stuff takes into account the fact that this is not a right triangle. That's what's actually happening here. If we were to go through the development of this, you would see that happening. For our purposes, suffice it to say this. If you start with side A, you must end with angle A. If you start with side B, you must end with angle B. If you start with side C, you must end with angle C, and vice versa. If you know you're ending with angle C, then you must start with side A. The first letter you write and the last letter you write need to be the same letters. The difference is this is capital, this is lowercase. Lowercase, uppercase. So what you start with and what you end with are the same. And there's more to it than that. Notice we have this minus 2ab times cosine, minus 2ac times cosine, minus 2bc. Notice that these two multipliers are these two values. These two multipliers are these two values. These two multipliers are these two values. Now the 2 just is part of the formula. It's like in the quadratic when you do b squared minus 4ac. That 4 is because it's part of the formula. Well, this 2 is just part of the formula from the law from when we developed this. So that's just part of the deal. But notice, if you start with C, you end with angle C, and whatever letters here, these are the other two values, those have to be the same sides used here. So what that means is you don't have to have them all written down necessarily even, because this is easy to memorize. Suppose you're given some information and you're working with angle B. Then what do we know? We know it's going to end up with cosine B, which means you have to start with side B, which means these need to be the other two. The order is irrelevant. I just use alphabetical. But then it's minus 2 times, remember what these multipliers? These multipliers are these two values again. And then we have cosine of, and the letter you end with is the same as the letter you started with, but it's got to be uppercase. So similarly, suppose we know we're using cosine of A. Then what do we know? We know we're starting with A squared, which means these need to be B squared plus C squared. Either order is fine, doesn't matter. I just use alphabetical. Minus 2 times, what are the multipliers? The multipliers are these two letters, B times C times cosine A. So it's not hard to know which version to use. It's only one law, but it's stated 3 different ways based upon which angle you happen to be discussing in your particular problem. So this is the law of cosines, but this is the law of sines. One other bit over here. We actually have, there's just one statement, but it shows up three different ways. There actually are three equalities here. Do you see all three equalities? Look, we have that ratio. Sine A over A is equal to sine B over B. Sometimes you will use that. You'll leave off the C's. Sometimes you'll leave off the A and you'll just use those two. And then sometimes you'll leave off the middle and you'll use the first and the last, which are equal. So which one you pick depends upon what pieces of information you've been given in the problem and what piece of information you're trying to find in your particular problem. So law of sines, it's one law, but it sort of shows up as this extended, and there actually are three equations here. There's an equation, there's an equation, and there's an equation. The law of cosines. There actually is only one law of cosines, but it shows up three different ways. We might as well list our third way. We started with A, we started with B, we should be able to start with C, and we should be able to make this happen. If this is C, then this has to be the other two, A squared plus B squared minus, it's always 2, and then these two sides become the multipliers. And then what goes in cosine? Cosine is the angle. Whatever you started with, you end with. And so it's not hard to know. It's not hard to actually keep this in your mind. You don't even need to, of course. You can simply have them all written down, and then you choose the one which is going to be applicable for your particular problem. The subsequent videos will be talking about how to actually solve the triangles. Once you know what's given, we'll be doing some specific occurrences and practice those. And I think you do 2 or 3 or 4 of these, and you start to have the law of sines and law of cosines down pretty well.